of recommendation system, how drastically the company's revenue increasing, maybe Amazon 35% revenue increase, or maybe YouTube or Netflix, etc. How the users are choosing movies or videos directly because of recommendation system. Of course, we are also happy because I already said. Now here, let us assume with simple graphical representation, you can understand better. So let us assume, so these are the movies. We have a database with a set of movies. We have these are the movies, maybe the action movies and thriller movies, romantic movies, devotional movies. Whenever if we go for any OTT platform, we have various kind of movies. Now, what basically recommendation system will do? So let us assume this is my interest. So my interest is comedy movies, or maybe my interest is action movies. Sometimes combination also possible. So combination of comedy and action, or combination of comedy, devotional, action. So that depends on, that's why we can do, there is a huge scope for research also. So let us assume my interest is comedy. What basically the recommendation system will do? It will act like a filtering system. So it will filter, and these are the movies which I'm not showing interest, and I'm showing interest only for these movies. So that's why the recommendation system recommend these movies to the customers. So based on many different factors, it may be similarity, or it may be based on the previous activity, etc. But finally, it will act as a filtering system, and that's why it is a subset of filtering system, that we can call it as information filtering system, and it will recommend these are the movies to the users. So let us assume A is a user, so these movies will recommend to the user because his interest is only comedy. Because of that reason, these movies will recommend to the user. So whether he's going to watch or not, that is left to the user. So it's not guaranteed that whatever movies or whatever videos recommending to the user, he will watch everything, or whatever products or whatever services providing to the customer, you will accept or not, that depends on the user. So there is no 100% guarantee, but as per the statistics I have shown already, so 70% of the Netflix users are watching movies based on the recommendation, and 60% of the YouTube users are watching based on the recommendation, and 40% of the apps are downloading from the Google Play based on the recommendation. So that indicates that, so whenever recommendation is happening, so obviously most of the users are giving preference. So finally, we can make a conclusion. So basically, recommendation system is an information filtering system, and it will recommend the products or movies, etc., based on the user interest. It may be based on the similarity or etc. That we will discuss in detail how it will recommend with based on the various factors. By using use cases, we can understand. So this is a brief definition. So if anyone will ask what is recommendation system, is a filtering system, and it will recommend items or products to the customers based on their interest. And again, we'll get doubt. So how system will understand the user's interest, all those things. So that we'll discuss when you are going further consequence slides. You can understand in detail about that. So I already said we have a huge number of applications of recommendation. So streaming services. So every day we are being influenced with this recommendation streaming services, Netflix, YouTube, because of COVID pandemic. So now most of the time we are watching movies in streaming services, Netflix, YouTube, Amazon Prime, Disney platform, and Sun Next, like that we have so many streaming services. So there we can watch videos, or maybe it may be movies, or it may be web series, etc. E-commerce. So we have so many e-commerce websites like Flipkart, Amazon, etc., eBay, etc. So there in general we used to give order, maybe books, or maybe clothes, or it may be etc., jewelry, etc. So there also we have recommendation system. And healthcare and medical industry. So as per the statistics, so 15% of the companies are using recommendation system, and healthcare still lagging, only 7% only. So that's why by 2025, most of the companies also going to use this recommendation system because of huge number of applications, as per the statistics I'm talking. In finance and agriculture sector also, in agriculture sector also, so what type of crops we can recommend to the farmers, and what type of fertilizers, what type of pesticides, etc., recommendation. And social media, so LinkedIn, Facebook, because whenever if you open Facebook also, you will get recommendation of the friends, or whenever if you go for LinkedIn, recommendation of the, or recommending some connection, like that we are getting recommendation, maybe Twitter, etc. Even education service also, so maybe based on your profile you will get some job recommendation. One example is LinkedIn only. Whenever if you have some profile in LinkedIn, so based on your interest you will get recommendation of the jobs automatically. and e-government, library, tourism, hotels, like that. We have huge, that's why, etc. We have huge number of applications of this recommendation. That's why, so recommendation is one of the very, very important application of machine learning. Of course, we have now deep learning techniques also applicable for this recommendation system. Based on that, we can recommend products or movies to the customers. So we can choose. So the advantage is, suppose if we develop a model for e-commerce, maybe we can do some minor changes. Again, we can apply for other application also, maybe finance or maybe agriculture. Finance means like the banking sector, what type of schemes they have, new schemes, it will automatically recommend to the customers or maybe bank customers or users. Now we have various types of recommendation system. One is popularity based, and one is content based recommendation system, and one is collaborative filtering. But my scope of this section is collaborative filtering technique. Based on that, how we are going to recommend movies or how we are going to recommend products to the customers. So when you come to the popularity base, it is based on the trending. So suppose let us assume some trailer or teaser is released yesterday, maybe that is a more trending video, that at that time you will get automatically that recommendation. That is called popularity based recommendation. So we are not going to focus on popularity based as well as content based. We are focusing more on collaborative filtering. But popularity means based on the trending, automatically you get recommendation. Whenever if you take YouTube, let us assume yesterday some movie teaser released. So that is most of the people are much awaited trailer or maybe teaser, automatically you get a recommendation. But what is content-based recommendation? What is collaborative filtering? So this difference is very important. Based on that, we can go ahead and research in content-based filtering techniques, or maybe you can go ahead with collaborative filtering techniques. So depends on your interest, you can choose any one. But I am going to focus more on collaborative filtering techniques. That's why I will show some of the resources. Based on that, we can go ahead with other types of recommendation system for various applications, what I have shown in the previous slide. So coming to the collaborative filtering techniques, let us assume we have two users, A and B, and both watched the movies. Let us assume Crack and KGF chapter 1. So what it indicates, because A and B, I'm assuming two users, I'm looking for a generic, maybe AB, some names, whatever it may be. So both watched the movies KGF, Crack. What it indicates, so both are similar users. So that means these two users are similar. Maybe both are having same taste. Crack also action movie, that is Telugu movie, I think most of them knows. And KGF chapter 1, that is pan-India movie, that is an action movie. So both action, that means the similarity is different. Maybe both like the action-oriented kind of movies. So that's why they watch both. Suppose A watched the movie Bahubali, let us assume. So A watched the movie Bahubali. Because of similarity, whatever movie watched by A, automatically it will recommend to B. So that is called collaborative filtering techniques. Basically, the collaborative filtering technique looking for similarity between users. So whenever if I take here, so AB watched these two movies, which indicates the similarity between users. And whenever A watched the movie Bahubali, obviously they have already similarity. Because of that reason, whatever movie watched by A, automatically it will recommend to B. So this is called collaborative filtering technique. Suppose if B watched the movie, let us assume, so E watched the movie, let us assume Kantara. So that is the latest sensational movie. Obviously, this movie will recommend to A. So because they are similar users, because of that reason, so whatever movie watched by A, it will recommend to B, and whatever movie watched by B, it will recommend to A. So this is called collaborative filtering techniques that we are going to focus in our today's session. Whatever machine learning models, whatever case studies I'm going to explain, it may be healthcare or it may be movie recommendation or product recommendation. So this concept I'm going to consider. Based on that, we will see how we are going to recommend products or movies to the customers. Hope it is clear what is collaborative filtering. Here, basically, we are looking for similarity between users. Based on that, it will recommend movies. It may be products also. Here, I'm giving specific to movies. It is applicable to product. It is applicable to healthcare industry. It is applicable to other sectors also, what I have shown in the previous slide. When you come to the content based, because collaborative filtering, it's clear, because we are looking for similarity between users. Based on that, it will recommend. What about content based? Because we should know the difference. Because popularity based means there is no issue. Based on the more trending, it will recommend automatically. And in collaborative filtering process, we are looking for similarity. But what about content based filtering? So in content based filtering, let us assume A watched the movies, movie 1, movie 2, any one of the streaming services, let us assume Netflix or Amazon Prime. So he watched both comedy movies. So what it indicates, so he likes more comedy movies. Let us assume today 3 movies are released in the same OTT platform. So movie 3, that is action movie, movie 4, that is comedy, movie 5, drama. You can see after the session, you can open any one of the OTT platforms. Let us assume Amazon Prime. Movie name down, you can see comedy, action, thriller. Like that, you can find the generic also. That means category of the movie also you can find. So here, movie 3, movie 4, movie 5, these are the 3 movies released in OTT, because every day so many movies are releasing the OTT platform. Now, how recommendation system will recommend which movie to the user? Because based on the past activity, because user used to watch only comedy movies, that is movie 1, movie 2, whatever it may be, past profile, the past activity. So automatically the recommendation system will recommend movie 4 to the customer or user A. Why? Because why? Already based on the profile, so always used to watch comedy movies. Because of that reason, so movie 4 will recommend to A. Again, here you will get doubt. Suppose I am not watching so far any movie, in what basis it will recommend? So that is called cold start problem. This type of issues are there. So many issues also there. That is called some of the challenges, or maybe some of the issues or problems. So that we can take it as one of the research problem, that we can go ahead with research also. That is called cold start problem. Maybe you can check it in Google. So what is cold start problem? So cold start problem is so far not watched any movie, but how it will recommend means, so that type of things we can call it as a cold start problem. So this type of research is also going on. So how to solve this type of cold start problem, based on that how we are going to recommend movies or products to the customers. So I hope you understood what is content based also. Just we have to look for based on the past activity or based on the user profile, the movies or products are going to recommend to the user. Suppose if I take our education system, field, suppose I used to give so far C, C++, Java program. These are the books I have ordered through Amazon or maybe Flipkart. Some e-commerce website, these are the books I have ordered and I already received. Maybe today, let us assume Python textbook or maybe R programming, PHY. So R programming or Scilab or MATLAB, any one of the programming language textbook is released in the market. That means in that website they announced, then automatically I will get recommendation. Why? Based on the past activity, I used to give order only for programming languages. So that means it indicates that the user is more interested for only programming languages textbook. So that's why automatically I'll get recommendation of this Python or R program or Scilab or MATLAB, whatever it may be, programming language textbook released, it will recommend automatically to the user. So maybe so far, let us assume I used to give order only beauty products. Let us assume maybe Fair and Lovely something. Any new beauty product is released in the market, then automatically it will recommend. Or maybe I used to buy only jewelries in the e-commerce website, then any new jewelry is released in the market, then automatically it will recommend. So this is the way the content-based filtering will work for the e-commerce websites, or maybe what we can call it as a streaming services. So you can see here, she used to give only beauty products. So because of that reason, so any new beauty product is released in the market, she will get recommendation. So that is called content-based recommendation. So hope it is clear what are the types of recommendation system. Popularity based on the more trending, and the collaborative filtering, that means based on the similarity between user, it will recommend movies or products. I will show case studies also for better understanding by using some of the machine learning models. And content based recommendation is based on the past activity, it will recommend movies or products to the customers. So we are going to focus collaborative filtering process. Based on that, how we are going to recommend movies or products to the customers. Even for healthcare sector also, how we are going to recommend drugs to the customers, or how we are going to recommend doctors or maybe specialists to the customers or maybe users. So we are going to focus on more collaborative filtering for recommendation system. That means we are looking for similarity between users. Based on that, how we are going to recommend movies or customers to the, products to the customers. Yeah. So up to here, just the theoretical parts we completed. What is recommendation system? That is, it is a basically filtering system, and it will recommend items or products to the customers based on many factors. It may be similarity, it may be past activity, etc. And what are the types of recommendation system we discussed? Now we will see some of the simple use cases. Based on that, we'll get better understanding of this recommendation system, and maybe you can implement for your research activities also, maybe for paper publications or maybe patent, etc. So I'm going to take one simple data set that is called movie data sets. Suppose if anyone wants to download, you can go through this website that is called grouplens.org. So here you can download that one. Here, just if you click this here, readme.txt next followed zip file. So then you can download that movie ratings data set. So based on that, you can apply any one of the machine learning models or any novelty, then you can go for better accuracy and you can apply for publications also. So the screenshot of the data set like this. So we have user ID. Of course, we can, if you scroll down, you can find more than 40,000, 50,000 records, data samples. But here I'm showing just first page of the screenshot. We have user ID. These are the attributes or fields, or we can call it as a features, and movie ID, and whatever it may be. We can assume either movie ID or movie name, and rating given by the user or customer. So here one more assumption, I'm assuming the rating scale is 1 to 5. So entire session I'm taking rating scale is 1 to 5. In general, whenever if you go for movie recommendation or product recommendation, the rating scale is 1 to 5. Suppose if you are traveling in Uber or Ola, etc. So after completion of your trip, you have to give rating. So the rating also you can find either 1 star or 2 star or 3 star or 4 or 5. Maximum rating is 5. Maybe some of the cases even 1 to 10 rating also there, but most of the cases what I have observed in the literature, the rating scale is 1 to 5. Suppose if you have 1 to 10, you can go ahead accordingly, or maybe you can go for normalization, then you can apply your model. That depends on your pre-processing. But here I am taking rating scale is 1 to 5. Of course, even in this data set also, the rating scale is 1 to 5 only. So that's why here whatever rating given by the customers to the movies, so here available, and timestamp is not required for us. So I think you know what is the meaning of timestamps. So this is not required. So we have only 3 attributes. One is user ID, one is movie ID, and the rating given by the user. Instead of user ID, we are going to take username for better understanding. Instead of movie ID, we are going to take movie name or maybe product name, and rating in here, there is no change here. So this is a screenshot of the data set. So for further applying machine learning models or maybe other statistical measures for recommendation of the movies or products to the customers. So here in pre-processing, directly we can't apply. That's why what we have to do, we have to make it as a utility matrix. So we can call it as a user item matrix, or we can call it as a utility matrix. Just we have to make a matrix. So I am taking rows are nothing but users or customers. Columns are nothing but movies or items. So that is a thing we are assuming here. So rows are nothing but users or customers. Columns are nothing but items. It may be products, or it may be movies, or it may be healthcare sector, any symptoms like that. It depends on the application we can take as. And the entries of the matrix, the entries of the utility matrix are nothing but the ratings given by the customers or users. As you can see here, so user 1 given rating for item 1 is 5. That's why the entry is 5 here. And similarly, rest of the entries are not available. That means the rating is not provided by the user to other items. Maybe he did not buy items. That's why there is no rating. So similarly, user 2 for item 1, so rating is 4, and user 2 to item 2 rating is 4, and similarly user 2 to item 3 rating is 2, and the rest of the ratings also available. That means all the ratings are available for user 2 to rest of the item, all the items. That's why 4, 4, 2 available. And here similarly user 3 only 2 ratings are available, and user 4 only 1 rating is missing. Rest of the ratings are provided by the customer or user. So this is called utility matrix. So the ratings are missing here. Don't worry about that. So we will see further. That is our main goal or objective, that we will see what we are going to do here. So this is called utility matrix in the entire session. So this we are going to use as a input to the model. So this we can take it as a pre-processing step. First, we have to make it as a utility matrix, or we can call it as a user item matrix. And wherever entries are missing, no need to worry. We will see what we are going to do with that. And by using machine learning, after that, we will see how we are going to recommend items or products to the customers. Yeah. Now, basically, the collaborative filtering process, this here I'm giving a generic, whatever I have shown in the previous slide, that's specific to 5 users, 5 items. So here I'm taking N items, and I'm taking M users. Here you can see here. So whenever if you go for research paper writing also, you can't go for specific, you have to go make it as a generic. So that's why make it as N items and make it as a M users. So that's why items are I1, I2, IN, whatever it may be notation, you can assume according to that, or maybe in general, we can call it as a futures. If you are assuming, then F1, F2, F3, you can assume. Movies means M1, M2 like that. So now here, let us assume that these are the ratings are missing. Let us assume. So what we have to do in collaborative filtering process, so we have to find the rating. So wherever rating, that's why I said in the previous slide, some of the ratings are not provided by the customers, but no need to worry about that. So our goal is we have to go for rating prediction. So let us assume user 1 to item 2 rating is not given, and user 2 to item 2 rating is not provided, or maybe user I2 item 2 is not given. So what we have to do, let us assume user I2 item 2 is rating is not available. This rating we have to predict. This rating prediction we have to do. So that's why our aim is to go for prediction. So because machine learning is nothing but it is a tool to look for patterns in the data. Based on that, we can look for prediction or classification, but data is very important. Without data, nothing to do with machine learning or deep learning model. That's why data is a fuel that drives the machine learning engine. Always data set is very, very important. So here, whatever rating we are going to find here, based on that, the recommendation system will decide whether we are going to recommend item 2 to UI or not. That means user I or not. So that means basically our first intention is we have to find the rating prediction. So let us assume, so this rating prediction is, let us assume 4. We have to find. So how to find? Still we don't know. That is our main objective. First objective is we have to go for prediction as per the collaborative filtering model. After rating prediction, based on the rating prediction, the recommendation system will recommend, decide whether the item is going to recommend to user or not. But here we have a small constraint. I'm going to assume, because the rating scale is 1 to 5, that means 1, 2, 3, 4, 5. These are the ratings possible. So I'm fixing threshold is 4. Whenever the rating is more than 4, that means 4 or 5, then I'm going to recommend. Otherwise, I'm not going to recommend. This is my assumption. So I'm going to fix it, the threshold value as a 4 for recommendation of the items or products. So if the rating prediction is 4 or above 4, then I'm going to recommend. Otherwise, I'm not going to recommend. That developer will take care about this threshold value. But as per the application, maybe you can fix. It's no guarantee that always we have to fix 4. Maybe some applications we can make it as a 4 is the minimum rating for recommendation. Maybe some applications we can make it as a 3, or maybe some applications you can make it as a 2. So depends on. But as per my literature survey, what I have found, so some of the literature survey I found minimum rating is 3 for recommendation, and most of the articles I have found, so 4 is the minimum rating for recommendation of the movies or products to the customers. So here I'm assuming minimum rating is 4 for recommendation. Let us assume I have done rating prediction. Let us assume here 2, here 3, here 4, here 5. So for better understanding. Now this rating prediction is done. So, but still we don't know how I predicted. That I will explain through examples, but just I'm giving brief idea. After rating prediction, so because minimum should be 4, so we can recommend this item to customer UI, that means user I, and this item to user I, but these two items, item 2, item 1, not going to recommend to user I. What is the meaning here? Because my threshold is 4. Whenever the rating prediction is 4 or more than 4, that means 5, I am going to recommend products to the customers. Otherwise, I am not going to recommend to the customer. So that is a simple logic. Suppose if you are going to fix it as a threshold is 3, then I too also recommend to the user I. But as per my model, I have fixed minimum rating should be 4. So that's why I'm going to recommend. So this item to the customer, this item to the customer. So these are the two important steps here. One is prediction. Whenever the entries are missing, we have to go for rating prediction followed by recommendation. Out of n items, what are the items we are going to recommend to the user? That depends on the rating. So hope this is the brief objective of the collaborative filtering model. That's why I have specified already. My scope is collaborative filtering process. Based on that, how we are going to recommend products or movies to the customer. So hope it is clear. Now we will see how we are going to find the rating prediction, because still I don't know how to find rating prediction. Just I have explained. So this is the rating 4 to 1 like that. But after that minimum is 4 rating, then I can go recommend. Otherwise, I'm not going to recommend. But how to find that is important. Once if you find rating prediction, then automatically the system will take care. So this movie or this item is going to recommend to the user or not. That will decide, because it's very simple if condition. If a rating is greater than or equal to 4, printf we can make it as a recommended. Otherwise, not recommended. Over. That is very simple thing. But how to find rating prediction? There machine learning plays a vital role. So there we have to apply various machine learning models. Maybe we can go for Bayesian classifier, we can go for decision tree or support vector mission, random forest or deep learning technique, convolution neural networks, or maybe some other deep learning techniques, or maybe similarity measures like correlation coefficient, cosine similarity, or maybe matrix factorization method. Like that, there are a huge number of models are available for this rating prediction. That's why I said there is a huge scope for research also. That's why at the end of the session, I will show some of the resources, some of the publications. Maybe if you are interested, you can go ahead for the recommendation of the movies or products research also. So, but I will show 1 or 2 models, because it's not possible to do exactly, because it will take a lot of time to explain. If you take one matrix factorization, it will take 2 hours. If you take Bayesian classifier, I used to take more than 1.5 hours just for Bayesian classifier, how we are going to recommend movies or products to the customers. That's why I'm taking one simple model. Based on that, we will see how we are going to recommend movies or products to the customers. So here I'm taking one simple statistical measure that is called Pearson correlation coefficient. I hope all of the participants, whether mathematics or maybe computer science, irrespective of branch, this is studied in lower classes. So I think someone raised the hand. Yeah. If you have any queries later, also you can unmute and ask me, or maybe you can type your query in the chat box. I will read it and answer it. So after completion of this, I will give time for that discussion also at the end of the session. Or maybe you can type now also your query. Later I will read it and I will answer for that query. There is no issue about that. So here, by using that, how we are going to recommend movies or products to the customers. This is very, very simple, because these are simple mathematical concepts we studied in lower classes. That's why there is no issue with this one. So this is the base paper for this. So improved collaborative filtering recommendation through similarity prediction, because I already said we are looking for a collaborative filtering technique. There we are looking for similarity. That's why I have explained examples with some movies. So here we are looking for similarity. This is published in IEEE Access, IEEE journal. So that means we are focusing only for similarity. That's why I already told you we can go for Pearson correlation coefficient. So based on that, we can understand how we are going to recommend. So here we are looking for two users. Let us assume, I already said we have to look for similarity between two users. So let us assume U, V are two users. We have to find the similarity. So that is called SIM, or maybe we can call it as a correlation coefficient between U, V. And I will explain what is numerator, what is denominator. So numerator components are nothing but standard deviations. But I'll show the formula, exact formula, what we have studied in lower classes, and based on that, how we are looking for prediction. So this is the base paper. There we have these formulas, but better understanding I will show in simple way, because IEEE papers formulas also a little bit difficult to understand directly. Yeah. So here we have studied in lower classes X and Y. These are the two random variables. This is simple statistical concept. So let us assume X values 1, 2. Let us assume 4, 5. Whenever we are looking for correlation between these two random variables, we have to go for Pearson correlation coefficient. This is a basic idea. Again, you will get out what is correlation. So whenever if I take, let us assume demand and price. So whenever demand is more, price also more. Whenever demand is less, price also less. This is called correlated. These two variables are correlated. Demand and price are correlated because there is some relation between these two variables, these two items. So demand and price, that's why we can call it as a demand and price are correlated. That means, so whenever demand increases, price also increases. Demand decreases, price also decreases. We can call it as a correlated. Or maybe number of students in university, income. Whenever number of students are more, income also increases. Whenever number of students are less, income also decreases. So this we can call it as a correlated. Number of students and income of the university, both are correlated. So that means whenever if you want to measure the correlation between these two variables, we have to go for correlation coefficient. Because I'm giving simple theoretical example, anyone can understand. But if you have a data, let us assume I have a data, number of students, maybe let us assume X as a number of students, Y is income. So maybe the data is 10,000 records. So I can't observe based on that, I can't make a decision. Because of that reason, we have to go for statistical measure that is called correlation coefficient. By using that, we can establish the correlation, how much correlation between these two random variables or these two variables. Suppose if I take, let us assume rainfall, or maybe let us assume number of students in university. So maybe if today rainfall is more, number of students will increase in university? No. Whether today is no rainfall, whether number of students are decreasing? No. There's no correlation. That's why these two are uncorrelated variables. We can call it as a both are uncorrelated. Even whenever we go for any some of the newspapers like finance related newspapers, so today demand, price are correlated. Like that, we can find that type of keywords like correlated. So whenever if we take rainfall and number of students, there is no correlated. So obviously we can call it as both are uncorrelated. Now the question is how to measure mathematically. So because we have a huge data for X and Y, how to measure? For that, we have to go for correlation coefficient. This we studied in lower classes. So we are not going that much in depth deep learning, machine learning models. Very simple things only we are discussing. After that, I'll show slowly even some complicated things also for better understanding. So here we are taking X is one user. When I'm coming to the recommendation system, X is one user, let us assume U1, Y is one user, let us assume U2. Why I'm taking like this? I'm looking for similarity between these two users. Based on that only I can decide whether I'm going to recommend items to the customers or not, whether I'm going to recommend movies to the customers or not. That's why instead of X, Y, I'm taking U1, U2. Instead of R, I'm assuming SIM. So for better understanding, sim u1 comma u2. So this is a one notation. I hope it's clear. Now how to find equal to? So this is called covariance between two random variables. So CO of x, y. X is one random variable. Instead of that, we can call it as a u1 and u2 because I'm taking two users. So that is nothing but mathematically what's the formula for covariance of xy? Expectation of xy minus expectation of x into expectation of y. So don't worry about all those mathematical concepts, but we require these basics only. So this is nothing but summation xi minus x bar into yi minus y bar. So this is the way we can write numerator. Directly we can write the basic idea is covariance, then we can write it as expectation of xy into expectation of y. From that we return summation xi minus x bar. Xi is nothing but values of the random variable x, and x bar is nothing but mean of the random variable x. In similar way, y I and y bar. So that is clear numerator. And denominator, this is called standard deviation. So square root of variance is nothing but standard deviation. We know everyone knows what is standard variance also. Variation of the random sample observations. And this is the standard deviation of the user 2. That is called variable 1. So this is a simple Pearson correlation coefficient between two random variables. And that I'm going to apply to the two customers. So just I want to modify to the two customers. Let us assume A is one customer, B is one customer, and the notation is sim instead of R, and numerator. So instead of xi, I am making RAP. What is RAP? So let us assume A is a user and P is a product. Let us assume item. So try to understand what is RAP. So this is RAP. So that means the rating given by user A to product I. Let us assume 4. So previously in the formula xi minus x bar, here instead of that RAP, because I'm talking about recommendation. So whatever formula we have, just we are moving some translation to our application. So RAP means rating of user A to product P, or maybe movie, like that. So let us assume 4. And RA bar means so average value of the user A, and similarly RBP, the rating of the user B to product P, and RB bar means average value. Whatever formula I have discussed in the previous slide, just I want to translate to the recommendation system, and standard deviation of the user A and standard deviation of the user. So I think hope it's clear. That's why I explained in detail about that formula what we have discussed in previous slide. So same thing, we can make it as a small translation to the similarity between two users. A or B are two users, or maybe U1, U2 you can assume. Yeah. Now I'll come to how we are going to apply to our data set. So I already told you what is user item matrix, or we can call it as a utility matrix. So this we already discussed. So here we have all the ratings are available. Some rating is missing. So I already told you what is the objective of collaborative filtering. The main objective of collaborative filtering process is we have to find the rating. After that, whether item is going to recommend to the user or not based on the rating. That means rating prediction is the first step. So first step is rating prediction P. So let us assume rating prediction or P. And after that, we have to decide whether the item 5 is going to recommend to Dynamic or not. That recommendation system will take care, because here machine learning comes to the picture. Once if it is done based on the rating, automatically it will recommend whether item 5 is going to recommend to Dynamic or not. And I already told you the threshold is 4. Minimum rating should be 4. Then only it will recommend in the rating scale 1 to 5. Otherwise, it is not going to recommend. Now, the question is how we are going to find the rating prediction. So for that, I have explained correlation coefficient between two random variables. And same thing, we are going to apply correlation coefficient between users. Or we can call it as a similarity between users. I will show now. Yeah. Now, what we have, this formula I have explained clearly in the previous slide, that is a correlation coefficient between. Now, first we have to find similarity between Dynamic and Gopi. So that is called sim Dynamic Gopi, and we know how to evaluate. Just we can substitute all the values, whatever values. 5 minus 4. 5 is nothing but rating given by Dynamic to item 1. 4 is nothing but average value of Dynamic. And 3 is nothing but rating given by Dynamic to item 2 and average value of item 2, like that. That I already explained in the previous slide. Xi minus x bar into yi minus y bar, that is called covariance. All those things I have explained in the previous slide. So that values we have to substitute in the formula. Based on that, we got 0.853 is the similarity. So that means the similarity between Dynamic and Gopi is 85%. So 0.85 means 85% here. So we have similarity between Dynamic and Gopi is 85%. In similar fashion, we have to look for similarity between Dynamic to Sachin. Why I have here, you can try to understand. We are looking for similarity between sim within bracket Dynamic, comma I. I varies from either Gopi or Sachin or Vishnu. That means I equal to 1, 2, 3. Let us assume 1, 2, 3. 1 is Gopi, 2 is Sachin, 3 is Vishnu. But D is fixed. Why D is fixed? I am looking for who is more similar to Daivik. Based on that, we can go for rating prediction. That's why we have to look for Daivik to Gopi, Daivik to Sachin, Daivik to Vishnu. So we have already done, we have calculated similarity between Daivik to Gopi is 85% and Daivik to Sachin by using same formula 70%, 0.7. And while applying Daivik to Vishnu similarity minus means it's 0. No need to consider. That means 0% similarity. That means dissimilarity, or we can call it as a technically uncorrelated. So while writing research paper also, we can make it as a sim D comma I. Let us assume I equal to 1, 2, 3, or maybe 1 to n. We have n customers and we have to find similarity between these two users, and D is fixed. Similarly, if we are looking for other customers, that customer is fixed and we have to vary other customers for finding similarity. So finally, we have calculated the similarity between Daivik and Gopi and Daivik and Sachin and Daivik and Vishnu. Negative means we can take it as a 0 only. So no need to take it any, because uncorrelation, that's the meaning. So finally, you can see here, Daivik and Gopi, we have calculated the similarity is 85%, that is called correlation coefficient. And Daivik and Sachin, we have calculated 70%. And Daivik and Vishnu, we have calculated 0. So no need to consider. As you can observe that the highest similarity is Daivik and Gopi. So when you see the similarity, there is a huge similarity between Daivik and Gopi when compared to the other users. So here we have 85%, but others the similarity is less than 85%. So finally, we have make a conclusion. The highest similarity is Daivik and Gopi. Now what we are going to do further, whatever, because both are similar users, whatever rating given by Gopi to item 5, same rating we are going to consider. That is called rating prediction is 3. So this is the rating prediction we have to do by using similarity measure or similarity index. So hope you understood. So Daivik and Gopi having highest similarity because of 85%. Whatever rating given by Gopi to item 5, that is 3, same rating we are going to for Daivik to item. That means rating. So what is the rating prediction Daivik to item 5? 3. Now, as per our threshold value, minimum rating should be 4 for recommendation. Otherwise, not going to recommend. So therefore, the final conclusion is item 5 is not going to recommend to Daivik. Why we are not going to? Recommendation system won't recommend item 5 to Daivik because the rating is very, very low. Whenever the rating is less than 4, it is not going to recommend. That I have fixed. As a developer, maybe if you are going to fix as a 3 threshold, then item 5 is going to recommend to Daivik. But I already mentioned the threshold value what I'm going to fix for recommendation is 4. That's why whenever rating is 4 or 5, then item 5 is going to recommend to Daivik, otherwise not going to recommend. So therefore, the final conclusion is, so item 5 is not going to recommend to Daivik. So this is the simple statistical measure for calculating the similarity between users. Based on that, we can go for rating prediction followed by recommendation of the items or products or movies, whatever it may be, depends on the application. So in our case, item 5 is nowhere going to recommend to Daivik because the rating prediction is 3. As per our threshold value, minimum should be 4, then only it will recommend. So this is a simple example use case how we are going to recommend items or products to the customers. So I will show one small quiz to the participants. So here you can see which movie 1, movie 3, movie 4 will recommend to Vishnu by recommending engine using PCC. So whatever I have explained, Pearson correlation coefficient. So you can see here yellow, Vishnu to movie 1 no rating, Vishnu to movie 3 no rating, Vishnu to movie 4 no rating. So now what we have to do, which movies we are going to recommend to Vishnu, that we have to decide based on the PCC. That means based on the similarity between users. Now I will give the similarity measure also. After that, you can decide which movies are going to recommend to Vishnu. So similarity between Vishnu and, because it will take time to calculate, that's why I'm showing directly. Vishnu and Daivik similarity is 0.32, that is 32%. Similarity between Vishnu and Ramesh 0.73. Similarity between Vishnu and Somu is 0.21. Now tell me, so what is the rating prediction followed by which movies are going to recommend to Vishnu? So you can write your answer in the chat box. Just you can type it in the chat box. So two things. One is rating prediction for Vishnu to movie 1, Vishnu to movie 3, Vishnu to movie 4, followed by whether movie 1 or movie 3 or movie 4, which movies are going to recommend to Vishnu. So most of the things I have done, I have calculated already the correlation coefficient between Vishnu to other users. Only your part is rating prediction followed by which movies we are going to recommend to the customer. So just post the answer in the chat box. It's very simple quiz. Anyone can answer easily. Just we are looking for rating prediction followed by recommendation of the movies. We can post our answer in the chat box. Okay, fine. Yeah. Yeah, thank you for the response. Yeah. Jayanti madam, Hazar Hussain sir, Jayanti, yeah, fine, man. And Naveen Kumar sir, yeah, partially correct, sir. Yeah. Neeta Tummala, yeah, partially correct. Yeah, fine. Thanks for the response. So, yeah. So we have already done, yeah, a few more responses. Yeah, correct. Neeta Kumbala, madam. Yeah, fine, madam. Correct, madam. Yours is correct. Yeah, correct. Yeah, most of them answered correctly. Yeah. Okay. So I'll move to the conclusion for this quiz. Yeah. So we have, as you can see here, sorry. So we have calculated the similarity between Vishnu and Daivik is 32% and Ramesh is 73% and Somu is 21%. As you can see, Vishnu and Ramesh similarity is highest when compared to other users. That means whatever rating given by Ramesh to movie 1, just copy paste, the rating prediction is 5. And whatever rating given by Ramesh to movie 3, copy paste, the rating prediction is 1. Whatever rating given by Ramesh to movie 4, copy paste, that is 4. So rating prediction is done. So now out of these rating predictions, so minimum should be 4 for recommendation. So movie 3, 100% not going to recommend because the rating is very, very low. So movie 1, highest rating. So it will recommend. Movie 4, rating 4. So as per our requirement, threshold 4 is going to recommend. So movie 4 and movie 1 is going to recommend to Vishnu. So that's the final conclusion. So almost all the participants are responded correctly. So final conclusion is, so movie 1 and movie 4 are going to recommend to Vishnu because of highest rating 4 and 5. So movie 3 nowhere going to recommend because of very, very low rating. So this is a simple way to look for recommendation of the movies or products to the customers based on the similarity measure. Now coming to healthcare field or healthcare industry, how the recommendation system plays a vital role. So similar kind of example I will give. Maybe if you are looking for research oriented thing in the healthcare sector also, you can use this one. So my intention is how it is useful for healthcare sector, this recommendation system. We have so many applications in the healthcare sector also by using recommendation system. When you come to the machine learning, still we have so many other applications, but I am talking only for recommendation system, how it is helpful to the healthcare sector also. So here we have various scenarios for recommendation system. One is food recommendation. So based on that, lunch as a snacks, etc. So that will recommend drug recommendation. So based on the disease, let us assume I have a COVID. So what type of drugs I have to take? It will recommend. Or maybe I have malaria fever, or I have some dengue fever. What type of drugs I have to take? That will recommend automatically. We have apps also. I will show some of the things. And physical activity recommendation. So what type of physical activities? Morning, maybe you have to do walking, or maybe afternoon or evening. What type of exercise, physical activity we have to do based on the disease? So that type of recommendation. And and healthcare professional recommendation. So depends on the disease or maybe depends on the health conditions. It will recommend automatically the specialist. Suppose a person having cancer, it will recommend the cancer specialist. Maybe bone cancer, it will recommend bone cancer specialist. Maybe COVID-19, it will recommend a COVID-19 specialist. So this type of healthcare professional recommendation is also possible because of this recommendation system. So this, like this, we have a huge number of scenarios, recommendation scenarios in healthcare sector. I will show how we are going to recommend drugs to the customers based on the PCC what we have applied just now. So this is the data set. I'm taking synthetic data set for better understanding. If you want generic data set, I will show later, because there we have around 30,000 data samples are available. Maybe for research point of view, we can utilize the data set. Just here I'm showing one generic data set for better understanding. So here we have 4 patients. This is the historical data: patient 1, patient 2, patient 3, patient 4. And these are the attributes, or we can call it as a futures. So, or maybe fields: age, insulin level, glucose level, BMI, that is called body mass index, and BP level, and thickness, that is called fat level. So when you take patient 1, patient 2, patient 3, patient 4, all the values are available. And this is, we can call it as a historical data. Let us assume historical data, and he is the active patient. Today only he came. His name is, let us assume, Tom. He is the active patient, and I have collected what is his age and what is insulin level and what is, because when you take app, it will ask like this: insulin level, age, BMI, BP, etc. So now, what type of drugs or what type of prescription we have to recommend to Tom based on the historical data? Because already patient 1 to patient 4, already we have these these prescriptions are available in the data set. Patient 1 prescription is available because of historical data. Patient 2 prescription is available. Patient, this is a labeled data, and patient 4 prescription also available. But when you come to the active patient, is having, these are the symptoms or features. Based on these symptoms, which prescription we are going to recommend to the Tom? So for that, we have to look for similarity between Tom to other patients. Active patient similarity with patient 1, patient 2, patient 3, patient 4, and wherever there is a high similarity, that prescription we are going to recommend to Tom. That I will show now. Using, you can see here. So first we have to calculate similarity between Tom and patient 1, similar to what we have done in the previous slide, similarity between movies or maybe products. And Tom and patient 1 similarity is 86%. How we have to calculate also I have shown in the previous slide by using PCC, or you can apply cosine similarity. So many measures are available for finding the similarity between the customers or users. Here I have calculated similarity between active patient and patient 1 is 86%, and similarity between Tom and patient 2 is 51%, and the similarity between Tom and patient 3 is 49%, and the patient 4 is 4%. So that means I have calculated similarity between all the patients: patient 1 Tom, and Tom patient 2, and Tom patient 3, and Tom patient 4. All the similarities I have calculated. As you can see here, the highest similarity is with patient 1. So Tom having highest similarity with patient 1. That means when compared to other patients, so he is having 86% similarity. What is the conclusion? Whatever prescription is available for patient 1, same thing will recommend to Tom. So that means the prescription given to patient 1, same thing will recommend to Tom. So that is the final conclusion. So that means without consulting, without wasting time, directly I'll get a prescription. Now I can go to the pharmacy, I can get the drugs, whatever recommended in the prescription. So this is the one of the simple way for recommendation of the drugs or prescription to the customers or maybe users or patients. Based on that, we can save time, we can save money, we can save appointments, all those things. So this is the way we can look for recommendation of the prescription for any patients based on the, even you can observe that Tom and patient 1 similarity, age is almost close, and insulin level also almost close, and glucose level, okay, little bit variation, that's why we got 86%. BMI level, body mass index also almost close, BP level also almost close, and fat level, that's why both are having similar features, similar symptoms, or we can call it as a medical terminology, symptoms. So that's why whatever prescription patient 1 having, same thing will recommend to Tom. So this is the final conclusion. So you can see here, this is the patient 1 prescription, because whenever if you go to the medical shop, you can observe it today also. So RX indication indicates prescription. So you can see in that prescription RX is available. Whatever prescription for patient one, same thing will recommend to Tom also. Maybe whatever it may be, here you can see one tab EVOS Q6H, we don't know this meaning, and one refill and 650 mg tabs like that, same thing will recommend to Tom also. So this is the one simple way for recommendation of the prescription or maybe drugs to the customers based on the similarity. Maybe we can apply other machine learning models also. I'm not explaining, just I'm giving the simple use case. Based on that, we can go for other machine learning models also. You can apply it, maybe SPM or random forest decision tree, KNN, whatever it may be, deep learning techniques we can apply. Out of that, which one will give more accurate results, that we can make it as a final conclusion before going to the deployment. So even when you go for a specialist, professionalist recommendation, so we have apps, this type of apps also. You can type your symptom here, healthcare, maybe headache or maybe cough, or maybe if we click here, we can click cough, it will display. If we click here, maybe fever, it will display. So based on the symptoms, whatever we have entered, you will get recommendation of the doctor. Maybe I'm staying in Whitefield, so just I have entered, let us assume a headache or maybe fever, etc. I will get recommendation of the doctor from Cloud9 or maybe RxDX. I will get immediately near to my area only. So I'm staying in Whitefield, I won't get recommendation of the doctor from Hyderabad or maybe Kanakpura Road, etc. So this is one of the advantages of this recommendation system for healthcare professionals. Based on that, no need to search for any doctor. Immediately when I will get recommendation, I can take address, I can go and visit, I can go for further diagnosis also. This is very, very useful, and we can save time, we can save money, and there are lot of advantages for healthcare sector also. Still research is going on. If anyone interested, you can go ahead with the research for recommendation of the system for healthcare sector also. Even I'll show some of the data sets and that you can utilize for your research point of view also. So up to here we have done how we have to look for similarity between use. Based on that, how we are going to recommendation of the drugs or recommendation of the movies or recommendation of the products to the customers. Now here we have one classifier, machine learning classifier. Based on that, how we are going to recommend. So we have, I think, 50 minutes time. Yeah. So here, this is the base paper, a collaborative, because I already said we are focusing only for collaborative filtering technique. There we are looking for, so customers similarity, all those things. So here we have to go for Naive-based classifier, because we have various classifiers under supervised machine learning techniques, Naive-based classifier, decision tree, KNN, support vector mission, random forest, and even you can take deep learning techniques also. Based on that, we can look for rating prediction followed by recommendation. Here, this intuition, I'm not going to explain because it will take time to explain these mathematical models. So just I'll move to the directly. So here, I'll give otherwise basic idea. Yeah. So here, what we have to do, let us assume I'll give basic idea. These are the products P1, P2, P3. These are the products P1, P2, P3. And here we have customer, let us assume C1. So here ratings are available. Let us assume 4, 3, question mark. Now what we have to do here, so question mark means rating prediction. As per the Bayesian classifier, we have to find probability of y given x. And here, what is the meaning of y here? So y will take 1, 2, 3, 4, 5. That means all the probabilities we have to find, all the rating probabilities we have to find. X is nothing but previous ratings. Whatever ratings given by the customer 1 for P1, P2, that we have to take. That is called 4, 3. I'm giving basic idea. I'm not giving in-depth intuition or maybe explanation of this one because it will take a lot of time to explain. In general, I used to take 1.5 hours, 2 hours only for Bayesian classifier, complete mathematical intuition and how to apply for applications, maybe recommendation, healthcare, email spam filtering, cyber security, whatever it may be, other applications. Just I'm giving brief idea to go for further steps. So here, what we have to do, we have to find rating prediction, this one. For that, we have to find probability for rating 1, probability for rating 2, probability for rating, all the probabilities we have to calculate. After that, we have to look for highest probability. Highest probability rating, we can make it as a rating prediction. For example, so here for rating 1, I got 0.4 probability. Let us assume for rating 2, I got 0.6 probability. For rating 3, I got, by using Bayesian classifier, 0.7. For rating 4, let us assume I got 0.01. For rating 5, I got 0.3. Out of all the probabilities, what is the max value? 0.7. So what is the Bayesian classifier argmax? The maximum value corresponding to which rating? 3. So therefore, the rating prediction is nothing but 3. So this is the basic idea. So that means here we are looking for classifier in such a way that we have to find all the probability ratings, out of which we have to look for highest rating, highest probability. That corresponding rating is nothing but rating prediction. Now rating prediction is 3. Obviously, as per our threshold, P3 is not going to recommend to customer C1. So that is the basic idea behind this Bayesian classifier, how we are going to find the probabilities for all the ratings, followed by highest probability. We have to consider that rating, we can take it as a rating prediction, followed by recommendation. So that's why this mathematical aspect concepts or intuition, just I'm skipping because it will take a lot of time. So just here whatever I have explained here, you can see here. So y is nothing but rating prediction. I have calculated probability for rating 1, probability for rating 2, probability for rating 3, probability for rating 4, probability for rating 5, and denominator is rating given by same customer to other items. Now all the probabilities we have to calculate, out of which maximum probability we can consider, and that is nothing but rating prediction. This output is nothing but rating prediction. So here you can see here with simple example. When I calculated rating 1, probability is 0.2. When I calculated rating 2, 0 probability. When I calculated rating 3, 0.4, and 0.1 for rating 4, and 0.3 for rating 5. Out of this, what is the maximum probability? Max. What is the maximum? 0.4. Now what is argmax? The maximum probability corresponding to which rating? 3. So therefore, rating prediction is equal to 3. So try to understand, max is different, argmax is different. Max is nothing but maximum value. Argmax is means maximum value corresponding to the rating or corresponding to the value. Suppose if I take, let us assume x and y. Suppose if we take x value 1, 2, 3, y value, let us assume 4, 6, let us assume 4, 6, 2. Now what is the maximum value of y? 6. What is the argmax? 2. Try to understand, because I observed most of the people, argmax is nothing but max. Max is different, argmax is different. Maximum value corresponding to x value is nothing but argmax. Suppose if someone will ask what is the minimum value of y2, what is argument? The minimum value corresponding to the x, that is called argument. Suppose what is the maximum score in the class? 90%, let us assume. Suppose if I ask what is the maximum percentage, means 90%. Suppose if someone will ask what is argmax, this maximum percentage corresponding to the student, let us assume Ravi. So Ravi is nothing but argmax. That is the difference between max and argmax. When you open machine learning, deep learning, most of the pages we can find this argmax only, argmax, arging, like that. So this is the actual meaning of argmax. Now we have calculated maximum probability 0.4, and argmax means this 0.4 corresponding to the rating 3. Therefore the rating prediction is nothing but 3. So this is a simple basic idea I'm giving how we have to apply classifier for rating prediction, followed by recommendation. Because here the rating prediction is 3, which is very low. Therefore I'm not going to recommend product to the customer. So this case study also same thing, just I'm skipping here. Yeah. Now I'll move to the evaluation. Because when we go for machine learning, we have to evaluate the model. Then only we can say this model is the best. Because when you are writing research articles also, so after applying models directly, we can't make a conclusion. I applied this model and I got this accuracy, hence best. We can't say like that. We have to evaluate with other models also. Based on that, we can say this is a proposed model is the best. So hence we can go for deployment to the application like that. But how to evaluate? That is very, very important. We have so many evaluation measures whenever we go for classifiers. Just I'm giving one simple evaluation measure for this recommendation system, that is called root mean square error. So here basically we have two things. One is nothing but RI. This is the actual rating in the test data set, and PI is nothing but predicted data set values. RI is nothing but actual let us assume actual rating values. PA is nothing but predicted rating values. Let us assume actual rating is 5, predicted is 4. Let us assume actual rating is 3, predicted also 3, like this. So this is the this I'm taking as from test data set. So now PI is nothing but predicted rating, RI is nothing but actual rating, and N is nothing but number of data points. That means number of data samples, or we can call it as technically number of records in the data set. And why we have to make a square? Sometimes, so PI minus RI, maybe you will get negative. Because of that reason, we have to make it as a square. So when you make negative positive, if we add, we will get 0. It does not mean the model having 100% accuracy. Because of that reason only, we are making square. So each and every term having meaning. So we have to make a difference. That is called error. After that, we have to make a square. Why we have to square? Sometimes we have negative error also possible. When you make negative positive error, it becomes 0. It does not mean the mean square error is 0. That's why we have to make a square. After that, we have to make a sum. Because of mean, we have to divide by number of data samples. So that's why finally square root means square root. So finally, which is nothing but root means square error. So whenever RMSE value is low, then that is the best model when compared to other models. Suppose we have models, let us assume 2 models, M1, M2, and M1 RMSE value for the test data set is 0.3 and M2 is 0.1. Out of this, the low MSE value is for M2. Therefore, we can consider this is the best model. Hence, we can deploy to the application. So that's why evaluation. Maybe if we have other measures, we have to consider. Just I'm giving simple measure. Based on that, we can go for further enhancement of the other measures also. Now I'm taking, this is a simple example. So these are the ratings. Actual ratings are available here, as you can see here. Fourth attribute, fourth column, and predicted ratings also available. So now we have to make a square. Difference, make a square. Error square, and after that make a sum. 5.6 divided by 10 number of data samples, square root will get 0.75. This is nothing but root mean square error. So this is a simple way to calculate root mean square error. So we have to apply other models also. Based on that, whichever model giving less RMSE, that is the best model. Hence we can deploy to the application. That's why evaluation is very, very important in machine learning or deep learning models. Suppose I give one small quiz. So I have a movie data set and I have applied various models and I have calculated RMSE. Now tell me which model is the best for recommendation of the movies to the customers. So I have calculated RMSE for PCC, that is called Pearson correlation coefficient is 0.57. This is my RMSE value when I applied PCC for the movie data set. When I applied probabilistic model, that is called Bayesian classifier, I given brief idea about Bayesian classifier, but not completely, because I already told it will take a lot of time to explain in-depth mathematical intuition followed by case study. So I applied probabilistic model, 0.31 is nothing but RMSE value I got. And I applied cosine similarity. I already said we have so many similarities. So when I applied cosine similarity, there we are looking for angle between two customers or two users. I got 0.45 is the RMSE value. When I apply matrix factorization, this is called latent factorization or matrix factorization. This is based on the LU decomposition, what we studied in discrete mathematical structures in lower classes, or maybe those who prepared GATE exam also, you have this matrix factorization. So by using that, 0.43 is the RMSE value. So I have applied 4 models to the given movie data set. Now tell me which model is the best for movie recommendation, which model I can consider to deploy the movie recommendation. RMSE values are available for all the 4 models which I have applied to the given movie data set. Now which model we are going to consider for further step, that means deployment. All RMSE values are available. Yeah, someone answered. Yeah, Neeta, Dr. Sylvie, madam. Yeah, fine. Neeta, madam. Yeah, yours is 100% correct. Madam, doctor also almost close to the answer. Yeah. Okay, fine. So out of all the 4 models, what I have applied to the movie data set, so the less RMSE value is nothing but probabilistic model, 0.31. I already told you. So whenever if we apply, let us assume we have a data set, let us assume D, I have applied various models. Out of all the models, which one will give the less RMSE value? That is the best model. That means the error is very less. So therefore, out of which, so 0.31 is very less when compared to rest of the models. Therefore, probabilistic model is the best for movie recommendation. Hence, we can deploy to the application. So this is the conclusion. This is the final conclusion where we have started what is recommendation system, what are the types of recommendation system, and collaborative filtering process we considered, and we applied PCC method and Bayesian classifiers, and finally how to evaluate by using RMSE, and finally how to make a conclusion. Whichever model having less RMSE, that is called root mean square error value, that we can consider for the final model for the given data set, and hence we can deploy to the application. So there is no guarantee probabilistic model will give same for movie data set, maybe other data set. Let us assume product recommendation, or maybe some medical drug recommendation, etc. So depends on the data set, it may vary RMSE value also. That's why we can't say this model is only best for any application. We have to apply all the models based on the RMSE, maybe based on the other measures, we can decide this is the best and we can deploy to the application. So final conclusion is probabilistic model is the best for movie recommendation, because here I got 0.31 is the RMS value, which is very, very low when compared to rest of the other models. So this is the final conclusion. So even when you are writing research paper also, this is the way we have to follow. So introduction followed by literature, followed by methodology, followed by evaluation, followed by conclusion. So research directions. So maybe those who are looking for research in this recommendation, because it's a huge topic. So once if you develop any model, you can apply to all the data sets. You will get huge number of publications also. That is the secret behind this recommendation system research. So when you come to the research directions, because we are all faculty community, that's why I'm showing a brief idea about this. So if you are looking for complete details about recommendation, you can go through this paper, recommendation system principles, methods, evaluation. Around this is 25 pages paper. You can find complete details. This published in Elsevier journal. So maybe if you want after session also, you can send mail. I will share this one. And this is the drug recommendation data set. So here you can see drug name and drug condition and patient review and drug rating. So how we are going to recommend drug based on the patient condition and based on the rating. So this is very, very interesting research. If you are interested, you can go through the literature survey on drug recommendation system, and this data set only you can consider for that. And here rating along with review also added. That means we require some natural language processing concepts also, like stop words. We have some of the stop words also, so that we have to remove. So a lot of pre-processing also we have to do. So if you are anyone looking for research, you can take this data set and you can further go ahead for recommendation system for drugs. And here agriculture sector. So what type of crop we have to recommend to the farmers based on the NPK, temperature, etc., rice, or maybe some other crops. If you go scroll this data set, we can find so many other crops are available. Here label is nothing but crop name. So this is also maybe agriculture sector also you can go for recommendation. And this is also a very interesting research topic. Or maybe movie recommendation. This we already discussed. We have user ID, movie ID, and rating given. Maybe if you are looking for movie recommendation, you can go through with this data set and you can look for recommendation of the movies to the customers or users. And if you are looking for agriculture sector, you can go to this collaborative recommendation system for agriculture paper. There you can find complete details about how we are applying recommendation system for agriculture. And based on that, you can further enhance your research and you can go for publications. And further resources, if you are looking for further resources for recommendation system, hands-on recommendation systems with Python, maybe we can apply Python for implementation. So you can go through this textbook. Complete code also you can find. So it is open source, you can download also. It's around 150 pages textbook only. You can find complete information about recommendation system and how to do implementation. Based on that, you can go for any new models also for recommendation of the system. And coming to next one, always I used to refer this mathematics for machine learning. When you go for machine learning, deep learning, natural language processing, artificial intelligence, image processing, mathematics is very, very important. Without mathematics, if you are directly entering to this machine learning, deep learning, it is difficult to understand. There is no much use to explain to the students also. Maybe Python code copy paste and you can explain, oh, this is the code, you will get output prediction like that. But we should know exactly what is happening beyond that. For that, we should know mathematics. So that's why these are all comes under mathematical subjects only. So that's why mathematics is very, very important. That's why you can go through that mathematics. If you are weak in mathematics, if you are strong in mathematics, no need to go for higher mathematics, only basics only. So you can go through this mathematics textbook. This is also open source. In Google, you can find around 1,000 pages textbook. You can find complete mathematics. It is useful for deep learning, because when you go for deep learning, the mathematics is not that much easy. It's very, very difficult to understand some of the mathematical concepts in deep learning. So that's why I'm recommending this mathematics for machine learning. Those who are looking for further studies for deep learning, machine learning, not only for recommendation, even generic also. And for data sets, of course, most of them know Kaggle, GitHub, along with UCI machine learning repository. You can find all the data sets from this UCI machine learning repository, or maybe you can go for any other public repositories to download the data set for your research. So that was my talk. So I hope I explained completely about recommendation system and applications and models, followed by evaluation, followed by research directions, followed by resources. And still, if you have any queries, you can ask me. I'm happy to answer. But I have shown the path. So don't think the entire recommendation system completed. So just I have shown the path. Based on that, you can further enhancement of the recommendation. That's why I have shown some of the resources also. Maybe if you want, you can send me.
To give you a you can plot a line on a graph, and this is M is basically nothing. It's a slope, and X is your data point onto which you are just trying to just draw this line, and y axis is this, right? And the C is nothing. This is a y intercept. To simplify the thing, let me tell you what very you see to simplify this y intercept. You see, many a time it will happen that this line is not going to start from zero. For example, if I'm going to tell you that the relation between age and salary, right? So you can't start salary with the age zero. Maybe at the 18 or 28 somebody got job and then his salary is going to start. So at that time we'll have this value of salary you can start at the age of 18, let us say. So it will start from here. So this is called y intercept, right? So y is equal to mx plus c, where x is nothing, your data point, right? This m is slope, right? And this is y intercept. So what is going to happen now? You see, let me yeah, how to calculate slope and all you see, it's you're just learning since yesterday. So we can just set one thing. Let us suppose we have a data points, we are normally calling it as features, right? So that is x, and we know how to calculate this slope m, and we know what is the value of c, so we can predict y. So this is basically a predictive model, right? This is basically a predictive model. And to machine learning, you see, as per many of the, like if you go for the literature, it is not coming to the tech, means it's not a part of technology. It's a predictive science. Simple, it is predictive science, and we can apply machine learning where uh, there is no complex engineering, where you can predict something and prediction, maybe you see it's going to be work or not. It's not going to be a big deal. So like we can predict about the say, we can predict about like Dr. Soma Sekar was just discussing about the prediction that recommendation system. So it hardly matters that recommendation system is going to work or not. It's not going, heaven is not going to fall. So basically it's a prediction science, predictive science, right? But you can't use this in core engineering like the rocket science or so where there is too much precision is required. Okay. So yeah. So let me directly come to the regression. Yeah, it's basically a statistical method used to describe the nature of the relationship between the variables. That is basically a regression. It can be positive, negative, linear, or non-linear. Any type of relation can exist. So how to do? What type of relation is there? We'll have to understand. What kind of prediction can be made from the relationship? We'll have to just understand. So regression is going to answer these two following questions. What type of relationship is existing between the feature and label, or between the features? What kind of predictions can be made from this relationship? Yeah. So this two thing we are calling it as exploratory data analysis. Onto this exploratory data analysis we can work to predict something. So for PDA, that is predictive data analysis, EDA is very much important. We'll have to explore the data sets first, and then only we can go for the prediction. Okay. So, okay, I'm not going in detail about this all, what type of relationship is existing, dependent and dependent variable. Why? Because Dr. Singh has discussed yesterday. So no point of discussing same thing again and again. So let me, yeah, this is a thing we can discuss. Okay. So, although I think Dr. Singh has discussed a bit about this yesterday. So this is our x value, this is our y value, this is the plot of x and y. So on this x and y, we can just get the m, that is the slope m. Yeah, right. The formula to get m is this, that is x minus x bar multiplied y minus y bar, summation of this all, divided the summation of x minus x bar whole square, and we'll get 0.4. 0.4 is the m. So you see, x we are knowing, m we got, then you see y we can, yes, here this y is nothing that the mean of this all value y. X is the mean, you see, x is the mean of all this value. So y is known, m we calculated, x we know, c we can calculate. There is no problem. C we can calculate. So the moment we are calculating c, yeah, there is no when you calculate it, it will come around 1.2. You can calculate, yeah, right. So when we calculate C, so now what is going to happen if you're trying to find the Y value for any unknown X, you can use this formula and you can get it, right? So this is now the point is, if the Y you calculated, for any unknown X, what is the difference between the actual and prediction? You'll have to compare, and that will come under the that how your model is precise or what accurate model is. Fine. So this is and this linear regression model is called as ordinary least square model. This is the name we have given to this linear regression, that is ordinary least square. Fine. Now there is a y-axis. Normally we are taking at dependent, and x we are independent variables. This is our the line or line of regression, and you see this all are the values, actual values, and there is some predicted values. Fine. So this is the actual value, and this red point is my estimated value that my model has estimated this value. So this difference we are calling it as error. This difference we are calling it as error, right? And the goal is to minimize the error. Distance between the actual and estimated value, we need to minimize. Okay. So it can be univariate, multivariate. I think we are not supposed to discuss many things about this. As I told yesterday, this all point has been discussed, and why I'm here, I am here for the hands-on. So let me directly come to the hands-on. So while plotting, how to see the relationship? To see the relationship, we need to plot the we need to plot graph to find the relationship. Now you see, relation can be anything like positive relationship, negative relationship, linear relationship, whatsoever. So by plotting the graph, a scatter plot, we can see the relationship. You can see directly from the first and second, there is relationship between the dependent and the independent variable. But in the third graph, actually there is no relationship. So we can't use this data set for any type of predictive analysis or for any ML model. Okay, now there is, you see, when I'm trying to plot a graph and we can see there is a linear relationship, it's okay. We can go for the machine model. If there is curvy linear relationship, no problem. We can go for the analysis. But we can't go. Yeah, this curvilinear is not too much advisable. There should be some strong relationship. But if there is no relationship, so we can't use this data set for any type of predictive analysis. Okay. One more point we should take care about this homoscedasticity and heteroscedasticity. You see, the first term, homoscedasticity, is saying that the variance around the regression line is same for all values of the predicted variable x. Meaning, if you're trying to predict y for any value x, the variance will remain same across all this line of it. That's okay. We can go for the predictive analysis. But what if when the value of x is increasing, then the variance is also increasing. You see, in the beginning, the variance is less, but when we are increasing the value of x, the prediction y, we are getting predicted value, but you see the variance is very high. So that is called heteroscedasticity. So how to find? You can find it by plotting graph. You can find it by plotting graph. You'll see by analyzing your data that how it is working. Fine. So these are the feature we need to see before going for any supervised learning. And okay, so yeah, and the normal error term. While plotting the graph of error term, there should be normal distribution of the error term. This is one of the very important point to take care. If the error term is not normally distributed, there is no bell curve of this error term, then it is means see your model is either not good or your data to which you have taken is not, you have not properly understood, or there is some differences there. Okay. Okay, there is some of the evaluation matrix, that is the absolute mean error, mean squared error, root mean square error. Just before my presentation, Dr. Soma Sekar was also discussing this, evaluation matrices for the recommendation matrix. And there is one R square that is most you see used in this supervised learning. This is the R square, right? This most used. So let me directly come to the hands-on. Okay. So let me come to the hands-on. Yes. Okay. So let me connect. It is initializing, then it will connect. Okay. So you see, you have discussed about the supervised learning. Means Dr. Singh has discussed yesterday about the supervised learning, and he has discussed, I remember, this problem that the iris dataset includes 3 iris species with 50 samples each. 3 species, 50 sample each, means there must be 150 record, right? As well as some properties about each flower, that is column, means that is columns. Okay, means there are some columns which is going to give you the feature of the flower, and there is one column which is going to tell you which species of flower is this. That is the iris flower. So altogether there will be 150 rows, and there will be some columns. Namely, let me tell you the name of the column. The name of the column is sepal length, sepal width, petal width, and the class level. Yeah, class level, there is 3 only, right? Setosa, versicolor, virginica. But dependent on this feature, this 3 the flower species will differ. Like if the sepal length is this, sepal width is this, petal length is this, petal width is this, then we can label this iris flower as setosa, right? If there is some feature like this, then you can label this flower iris as versicolor. And if there is some feature like this, then you can label this class as virginica. So this is the iris flower. This is not a, you see, very rare flower. You can find it very easily. And sepal, this is, you see, in the flower, the upper part, we are calling it as the petal, and this lower leaves of a flower, we are calling it as petal, and this is called as flower base. The three part. This upper part, we are calling it as petal. This upper part, this is, we are calling it as sepal, and this black color, we are calling it as flower base. Okay. So there is width of the petal, there is length of the petal, there is length of the sepal, there is width of the sepal. So there is 4 feature here. There is 4 feature here, right? I think I'm audible. I'm not getting any. Oh. Priti, I'm audible.
Yes, sir.
So this is all feature. Dependent on this all feature, we can label this class. So this all are, you see, these are the X, that is the feature, and this is X1, X2, X3, X4. We can divide like this, and this is my label, that is Y, right? This all are the independent variables, namely, and this is my dependent variable, right? So what to do? First of all, I'll have to load this data set to process further. So how to load this data set? You can download from any of the depository. Fine. You can, if it is downloaded to you, you can just simply load it here. How to load? Very simple. You can do right click, or you can do from the menu options. You may go to where you have saved your file. So I have saved this iris CSV file somewhere in the data set. No, not here. Somewhere in the Python data set, and yeah, here. And I can open, you see, I uploaded. Fine. By default, we discussed yesterday, it's content directory. By default, we discussed yesterday during the hands-on. Fine. So we did it. But you just uploaded to Collab, right? You have not done anything extra. So you see, these all are the feature, this 4 feature, that is the attribute, measurement, dimension, and this is the class level. Now we need to import all the dependencies. Like we need to do some computation, statistical and mathematical, and we need some. You see, then we need to import NumPy. We discussed yesterday, and this is alias NumPy SNP pandas, because we need to hold data in rows and columns. So pandas is nothing. It's a 2D in-memory transit structure, right? It's a structure onto which you can load data in 2D in form of rows and columns. And what I'm trying to do, I'm trying to load this all iris data in 2D structure like Excel. So that's why we need a proper appropriate container. So pandas is a proper and appropriate container, 2D in-memory transit structure. That's why I'm importing this pandas, and we have given alias PD. Seaborn I'm importing just for the you see, to see the all the scatter plot and all. This is a better library. And matplotlib as plt for canvas to print this all. Fine. So let me import this all, right? I'll share this notebook, no worries. And I'll share this that handout also. Fine. So after loading this, after importing this all modules like NumPy, Panda, Seaborn, Matplotlib, after just importing all this module, we need to load the data. Data is I just imported to content directory, and then I need to load it. So you see, I need to just load this data to one in-memory transit structure, that is pandas. And pandas, if you remember, I have given alias PD. You see here, I have given alias PD, right? So what I can do, I can use this alias PD, and there's a method called read CSV. This is a method to pandas, read CSV, right? So read underscore CSV, and in the parenthesis, I can give the file name as parameter, that is iris.csv. Fine. You see, we are not supposed to give the path, because the by default you see, the directory is content only. If you are trying to save this file in some other directory, then we need to give the path. But here, no need to give path. You can directly write iris.csv. Fine. So what it's going to do, it's going to load this iris.csv, read this iris.csv, and it's going to just put all this data in 2D in-memory transit structure in pandas. And after that, it's going to create a data frame using pandas. And this is the name of this data frame, that is DF. You can give any name. That is, you see, identifier. You can give as per your own, DF1, DF2, or any as per your wish. Fine. So, okay. And after that, to this data frame, I need to see the save. Save is attribute. It's not a function, right? You see, there is no parenthesis after the save. So this is attribute. So this attribute is going to tell you that how many rows and columns are available to this data frame. Fine. So let me explain once again what I'm doing. You see, this is iris.csv is a file, comma separated value file. What I'm doing, to this comma separated value file, I'm just loading all its value to a data frame, pandas data frame, and then this all value will come to my RAM using pandas data frame, and that will be like 2D structure. And after just storing it to the RAM, I'm just giving I'm just giving the name to this data frame as DA. Fine. So this is the reference variable to this data frame. After that, I'm trying to see the same. This is the attribute to know what is the rows and columns available to this data frame. And then this is a method. df.head. So by default, this head method is going to give me first 5 records. First 5 records. If you want to see 10 records, you can give 10 as parameter. Fine. But by default, it is going to give me first 5 records by default, right? So you see, from comma separated value to data frame, and finally you are printing this data frame. Fine. This is the index number of the row, and this is the column name. Sepal length, sepal width, petal width, and species. Fine. So here we can discuss a bit the difference between the NumPy and Pandas. The NumPy is collection of, you see, homogeneous collection, but Pandas you can just store, you see, heterogeneous data, right? And to the Pandas you can give the column name and index value, the row name separately. But in NumPy it's index, that is order. You can access through 0, 1, 2, 3, something like that. But here you can give the column name, right? So it's 2D in-memory structure pandas that can hold heterogeneous collection. One more thing, the column of pandas data frame, if you are trying to separate, if you are trying to take separately, this is a series object. Why it is series object? We'll discuss, no worries. But as a whole, this is pandas data frame. It's 2D in-memory transit structure onto which you loaded this value of this file, that is arrays.csv. So this one feature, 2 feature, 3 feature, 4 feature, and this is my target variable. I guess, okay, I told you that there is 3 species, and we are trying to load 50 records of each species. So you see the number of row is 150 and the number of column is 5. 5 means 4 feature and 1 label, target variable. I guess I'm clear till this point.
Yes, sir.
Okay. So next, you see this df.shape is printing this 155 and head is printing this first 5 record. I told you, if you want to print 10 record, you can give 10 as parameter. There's no issue. Now you get 10. There is a method called tell. There is a method called tell. So with the tell method, you'll get the last 10 records. You'll get the last 10 records. Oh, sorry, you'll get the last 5 records, not 10. By default, it's 5, right? And if you want to if you want to give parameter till 10, then you'll get the last 10 records. Right? Is it okay?
Yes, sir.
Okay. So this is my first 5 records. Okay. Next, I want to see the unique species value. Unique species value, right? So yeah, this is column is species. So df dot species dot unique, this is unique, it's going to give me what is the unique value in this species. And as you know, there's only 3 value which is unique, although there is 150 record. But you see, Aries setosa, Aries versicolor, Aries virginica, these are the 3 unique value to this data set. Fine. So you can find any unique value to any column. Like you'll have to write the df dot the column name and then the unique. You'll get it. And the data type is object. This is all are the string objects. Okay. Now I'm trying to describe the whole data set. You see, I told you that before going for the ML model, we need to understand data. That is called the exploratory data analysis, right? If something is missing, if something is not there, then we'll have to just impute the value. Fine. That is called data wrangling. Fine. So first of all, we'll have to see the data. That is called, there's a method called describe. So it's going to describe all about the data set. Like the sir was saying before me that too much, yeah, he was discussing something about the mathematic modeling, and so he has referred some book for the mathematics. So you see, when you're going to see the description of data, you'll get all the description of this data set. You see, Description of data set, it's going to just work only on the numerical columns, not on the string columns. So you see sepal length, there is 150 numbers. Yeah, right. There is 150 record. Sepal width 150, 150, 150. It's okay. The mean to sepal length is 5.84. Now mean, what is mean? Mean, everybody is knowing it's a average, right? So the mean of this sepal length is this. The mean of this sepal width is this. Petal length is this, and petal width is this. Okay, and the standard deviation of to all this mean value, that is the minimum value to the sepal length is this. Then the maximum value is, you see at the last, it's here. The minimum value to the sepal width is this, and the maximum value is 4.4. The petal length, the minimum value is somewhere here, and maximum is here. Petal, you see, this is 25 percentile, 50 percentile, 75 percentile. Percentile is very important to know if there is any outlier available, right? If there is some outlier available, then we can just discard it. Outlier, I'm not saying that outlier is always we need to discard. Sometimes outliers are good also, right? But many a time it may happen that you'll have to take care of the outliers. For example, if you are teaching some BTech students, there's a batch of 60 and you're trying to calculate the average age, okay, so you'll get around 18, 19 or 18 or somewhere 19, the minimum average age. But try to understand a situation that there is 3 students who are learning just in that group only, that BTech student, and they have been sponsored by government of India, by some you see some ministry, and their age is around, you see, 50. So when you are going to add this 50 to the averages, you see you'll not get to the correct value. So that is outlier to this data set. So you can just remove them, right? So yeah, but let me tell once again that sometimes outliers are okay. There is no problem. We can use them also. It's not always advisable to just drop them. Okay. Now, you see, you have seen that this description has not included this species, right? So to include all, we need to give one more parameter to this describe, that df.describe include is equal to all, right? So if you're writing include is equal to all, then it's going to include non-numerical value also, because you see the species was not non-numerical, right? So you see here you got a species also, right? Now, while including this species, you see there is 150 value. It's okay, no problem. Unique is 3. There is fine. Frequency is 50 because each species, I told you in the beginning, there is 50. And rest like the mean, you can't find the mean of a string. You can't find the standard deviation, minimum value 25 percentile, 25 percentile, 50 percentile, 75 percentile, maximum you can't find. That's this value is not available. Fine. So nothing to worry. If an n is coming to some string type of column, so nothing to worry, right? It's okay. Okay, fine, fine. Okay, now we need to see if some record is having the values missing. To know if there is some null value in the column, then there's a method called isNA, that is null available, whether the null is available. Dot sum, there's a this is called chaining. From one method you are trying to call another method, this is called chaining. So df dot isNA dot sum, then you'll, if there is somewhere, if the data is missing, you'll get it. But I think actually there is no null value, so your data is clean. You see, sepal length, there is no null. Sepal width, no null. Petal length, no null. Petal width, no null. Species, no null. So your data is clean. Fine. So after your data is clean, now, yeah, if you want to count the value count, species value count, yeah, you know that it will give 50. You see, df dot species is also okay, or df hard brackets, and then you can write the, you see, codes dot value count. It's also okay. There is no problem at all in both the way, right? So you'll get 50. What I'm trying to say, you can write like this also, or you can write like this also. Dot space, right? Both is okay. But just remember one thing. If this column is having one word, then only you can write with dot. If this column is having two words, then you can't write with dot. At that time, you'll have to write like this only. At that time, you'll have to write like this only. There's no other option if it is having two words, right? So both is okay. Okay. Now, this is time to see my data, right? I'm trying to count of each kind of flower species by creating a bar plot using pandas. So I'm trying to create a bar plot. Fine. And you'll see, I know this species is 50. So the bar will be very, you see, very much similar, right? So I'm trying to plot a bar of a species, and you know what the answer means, what type of graph I'm going to see. Yeah, you see, all 50, right? All 50. This we are knowing. Setosa is 50, versicolor is 50, virginica is 50. So all 50. Fine. Now there is one graph we are calling it as pair plot. So pair plot is nothing. Here I have given description also. The pair plot uses two basic figure: the histogram and a scatter plot together. The histogram and a scatter plot together. The histogram on the diagonal allows us to visualize the distribution of single variable, while the scatter plot on the upper half and the lower half triangle shows the relationship between the two variables. So this is called pair plot. Why it is called pair plot? Because we are trying to plot two diagrams together, histogram as well as scatter plot. Right? Right? Say something.
Yes, sir.
Oh, very good. Okay. Okay. So this pair plot is available with the Seaborn, and if you remember, we have imported Seaborn as SNS. So SNS dot pair plot, and in the you see parameter, I'm just passing all the data frame. Data frame means the iris data frame, right? And then I'm trying to plot this, and if you remember, Plotly, with Plotly there is I've just imported with PLT. So this is canvas. So onto this Plotly canvas, it is going to show me this pair plot, right? So you see the pair plot. Pair plot meaning histogram diagonally and a scatter plot at the, I think it's a big one. So let me minimize a bit so that you can understand, and then I'll again make it, yeah, more visible. Okay, so this is pair plot. You see, this is histogram diagonal, and if you can see, this all scatter plot is mirror image. You can see, you see, this and this is same, this and this is same, this and this is same, this, yeah, right? So this is mirror image actually. So you can consider only part. If you are not saying the one half, no problem. So this is actually a mirror image, fine. So this is the histogram at the diagonal, and this is the scatter plot at the upper half and lower half. Now, by seeing this all data, we can find there is a strong relationship, and after observing the strong relationship, we can go for the supervised learning, right? That is the OLS, fine. That is the linear regression. Now you see, you can't find any relationship on this data set, yeah, or very weak, between the sepal width and sepal length. Sepal width and sepal length. Actually, sepal width and sepal length, you see, very weak relationship. Here we can find some relationship between the petal length and sepal length. Yeah, here we can find some relationship, right? But you see, there is very strong relationship actually between the petal length, you see here, petal length and petal width. Petal length and petal width. Very strong relationship. So this is called exploratory data analysis. While just exploring your data, you'll have to observe what type of relationship is this, and then you can just choose your feature, what feature you are going to use for OLS, that is the linear regression. Am I clear till this point?
Yes, sir.
Okay. So let me minimize once, maximize once again. Otherwise, you will not see thoroughly. Right. Fine. So what we concluded? We concluded there is a strong relationship between this petal length and petal width. Fine. So I have given this all comments here. I have given, right? Now we can see some correlation matrix. I remember just Soma Sekhar sir was discussing this point about the correlation matrix and all, right? So we need to just see the correlation matrix. Fine. So here I have given you some comment about this correlation matrix. A correlation matrix is a table showing correlation coefficient between the variable. Each cell in this table shows the correlation between the two variables, right? A correlation matrix is used to summarize data as an input into more advanced analysis and as a diagnostic of advanced analysis. Fine. So let me show you the correlation matrix. Very simple. Yeah, as sir was saying, no need to go much about, you see, the mathematics. One liner code is enough. That is df dot, you see, CORR. This is the correlation function, and it's going to show you the correlation matrix. So this is basically, yeah, you see. Now, from here also you can find the correlation between the two features. You see, diagonally there is only one. Why? You see, sepal length to sepal length highly correlated. No. Sepal width to sepal width highly correlated. One. Petal width, petal length to petal width highly correlated. Petal width to petal width, yeah, it's highly correlated. So diagonally you'll find only one only, right? And if again, it's like pair plot. It's like pair plot. If you see the upper half and lower half, it's a mirror image. So don't consider the both part. Just consider only one part. Yeah, we seen in the pair plot that the petal width, yes, yeah, and petal length is highly correlated. You see in the pair plot. You see, these two features are highly correlated. 0.96, 96% it is correlated, right? 0.96 correlation is there. Some features are negatively correlated. Don't consider, like you see, sepal width with petal width, it's negatively correlated. This sepal width with sepal length negatively correlated. So we are not supposed to use this feature. One more correlation I can find that the sepal length with the petal length, it's 0.87. But I can find the good value, that is 0.96 with the petal width and petal length. Yeah. So these two feature we can use for this ordinary least square, that is the linear regression. Fine. You see? Okay. Now there is one more thing, more technique to find the correlation or to explore the data, that we are calling it as heat map, right? We're calling it as heat map. So how to do? You see, I'm just passing this correlation matrix as a parameter to heat map. Heat map is a method of Seaborn, right? It's a method of Seaborn. So what I can do, just I'm creating one, you see, df dot correlation method, and I'm just storing this data to CORR, and then I'm calling this Seaborn.heatmap, and I'm just passing this all data as a parameter to heatmap, and annotation is equal to true. There is true parameter. Fine. So just try to execute it. Nice. You'll get a heat map. I think again I need to do some minimization. Yeah, maybe it's okay. It's okay. Okay. So this is basically heat map. You see. Now the heat map is you see, you'll have to just interpret it. It will it will start, let us take in both ways, from the darker to the lighter or from lighter to darker, as per your convenience. The darker the color, sorry, the lighter the color, they are most correlated to each other. As you see in the correlation matrix, you see all diagonals are one, because the sepal length with sepal length is highly correlated. So we are not going to consider this all the diagonal feature, diagonal values, and both are the you see mirror image. So consider only one. So now you can see there is 0.96 correlation to which feature? Petal length with petal width, right? 0.87, you see the color, it's more darker to 96, right? So it is petal length with sepal length, right? So this all technique is just to understand your data, what feature you are going to use. You see, you can't just go randomly. That you'll have to justify why you have used this feature, why you are using this feature for this regression model, right? So, okay. So we seen it now. Okay, leave it. Just try by yourself. I'm not going to discuss this all. I'll share this all notebook with you. Now, the applying of machine learning to predict the flower species. Okay, so what is steps which we are going to follow? You see, split. First of all, we'll have to split the whole data set. You remember how many rows are there in our data set? How many rows are there in our data set? Am I audible?
Yes, sir.
How many rows are there in our data set? How many records are there? Somebody saying 50. No, 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 no. Rows. I'm asking rows, right? 100. No, it's 150. 150. There is 3 species, 50 each. So 150. So 150 rows are there, and there is 5 columns, right? 5 features are there, and 150 records are there. Okay. So you see, what we're trying to do, we are trying to split our data set into training and testing, right? Why it is required, you see, because if I'm going to train my model with all 150 record, so when you're trying to predict with some other value, so that other value, uh, you see, it will be some alien record to this model, right? And moreover, we need to find the efficiency, accuracy of my model. So what we can do, we can just split our data set into 2 parts, that is training and test. Now there is debatable, this is a debatable thing, that how many training, how percentage we are going to give for the training and how much percentage we are going to give for the testing. As per me, you see, somewhere 70-30 is okay, and yeah, 75-25 is also okay. But yeah, if your data set is very large, like in million and billions, you can go for up to 95% training, 90% training also. But if your data set is very less, then think twice before doing this, right? uh, yeah, this is, you see, the recording is going on. Otherwise I can give some you see, some example which is very unofficial, like normally we used to give students a question bank, that is what records it, onto which there is some we are going for this training for the IA, and there is test for the final, right? So okay, let it leave, this is not a very good example to discuss. Okay, so we need to split a data set with training and test data set, right? And we need to divide the data set. My data set is having 150 records, fine. So okay, so after splitting, we need to apply algorithm on the training, and after implementing this algorithm on the training, we'll have to test the algorithm with the test data set. Fine, I'll discuss wait for a while. Now you see the data set, there is we need X as 4 features and Y as label. Y means my species, X is my sepal length, sepal width, petal length, petal width. So we need to create X and Y. So what I can do, I can put a species column in Y, and I can put rest of the species column, means sepal length, sepal width, petal width to X. You see, normally it's a convention. As X comprises more than one column, so normally it's a convention, it's not rule, right? So we are just putting this X as capital just to denote it's a combination of many features, right? So what I can do, df is my data frame, dot drop is a method to which you want to drop. So I'm dropping a species, right? So when you are dropping a species, what left? There is 4 column left. Sepal length, sepal width, petal length, petal width. Fine. So all 4 column will come to X, and X is equal to 1. You see, when you're writing, this is second parameter, X is equal to 1. When you're writing X is equal to 1, means you're trying to drop the record column wise. You can delete the record row wise also, right? So that's why, but here you're trying to drop this species, it's a column. So that's why you'll have to give this parameter, second parameter, axis is equal to 1, because you're trying to drop column. Okay, so when you drop the species, what left? What left? When you dropped a species, what left? Kindly interact. If you dropped a species, what left? When we dropped a species, 4 feature left, which is a part of this capital X. And we stored the species in Y. Now I want to see the shape of X and Y, right? So you see, now what happened? What happened? There is 150 record with 4 column in X, and there is 150 record with one for sure only one column, that is a species. So this is my Y and this is my X, right? Now what to do next? What to do next? You see, now after this we need to split our record in train and test. After that we need to split our record in test and train. So as I told you that we need some training data and we need some testing data. Fine. And this is debatable topic that what will be the you see percentage of test and train. Fine. This is 150 record only. So what I'm trying to do, I'm trying to split in 25% as test and rate 75% as train. Fine. So this from sklearn model selection, I'm importing test and train. From sklearn linear model, I am importing logistic regression. Fine. And from sklearn, I'm just importing this matrices for accuracy and all. Okay. So what I'm doing here, I'm just creating here. You see, there is four values: X train, X test, Y train, Y test. Right. So test train is split. You see this test train is split. Parameter is capital X, that is feature, small y, that is label, test size 0.25, that is 25% as test, rest 75% as training, and random state is equal to 1. I'm going to discuss you about this random state. Give me a moment. Fine. So what is going to do? It's going to split my data 150 record into 75% as training and 25% as test. Fine. Random state 1 meaning you will have to give some random state, because you see every time you are going to just run this model, so every time it's going to take randomly, means it's not going to take sequentially 75% as training and rest 25% as test. So it will take 75% random selection of training and random selection as test. Let us say first record it has selected 3, second it has selected 7, third it has selected 9, something like that. This is the random selection. Okay, so why I'm giving random state is equal to 1? If I'm not going to give this, then what will happen? Every time it will take different test and different train. So what will happen that when you are doing some modeling, your answer will be different. But when you are trying to present in front of client, your answer may differ, and that why it will create confusion. That's why just give a random state some value, that seed value. We are calling it a seed value. So random value is equal to something, one, zeros, anything, that is called seed value. So we have just split it in trace and train, right? So here we got some 75% train data, 25% test data, 25% train level, and 25% test level. After that, we are going to implement the model. So this we are trying to implement logistic regression. Regression is having two parts: linear OLS, that is ordinary least square, that is linear regression. Another we are calling it as logistic regression. Logistic regression is basically a regression model which is going to give output in a class. You see, logistic regression can linear regression can give you can predict any value between minus infinity to plus infinity, right? But the logistic regression is going to predict some value within a class. Here the output is of 3 class, right? There is no it's not going to predict any value between minus infinity to plus infinity. No, it's not possible. The value should fall between these 3 classes, like the Setosa, Virginicolor, or I don't know what was the name, versicolor or virginica, right? So these are 3 classes. So in that case, we are not supposed to use the linear regression. We are supposed to use the logistic regression. So logistic regression is going to predict some value within class, right? So what I did, I have just created, instantiated the logistic regression, and then I have created a reference variable called model. And then model.fit is a method in which I'm just giving 2 parameter, that is x train. X is what? X is our feature. How many values are there? 75% random values are there of 4 feature. What is that?